Hey guys, so today I'm going to show you how to balance out this equation. This problem is going to be very similar to all the other problems that I'm giving you on your worksheet. So this is going to be number 5 from assignment 2.6.3. And so this is how we're going to do this. So I want you to understand that there are two parts to this. So there is a reactant side and a product side. These are both split up by this arrow right here. And so I'm going to give you a metaphor. So this is the metaphor. So let's treat our reactants kind of like ingredients. The ingredients in a recipe. And then your products are going to be like maybe some cookies or a cake, anything, right? And so this right here, this follows a recipe, right? So the recipe says that 1 pound of flour will give you 60 cookies, right? 60 full-size cookies. What if I asked you, could we make 1,000 full-size cookies with the same 1 pound of flour? Well, no, not really. You could probably make 1,000 cookies, but they would not be the same size as the 60 that this recipe is telling you, right? So what we're trying to say is that what we put in must also come out from this this exchange, right? So that is the balancing that we have to do. So let's see, let's blank this out, let's clean this up. So this is what we're going to do. I'm going to split this into a left and a right side. And my first step is going to be, I'm going to list out all the elements that I have on each side. So on this side, on the left side, I have hydrogen, I have oxygen, and I also have nitrogen. Same thing with the right side. We're going to have the same elements, so hydrogen, oxygen, and nitrogen. The next thing that I'm going to do is I'm going to try to add up all of the subscripts, all of the atoms that each of my elements has on each side. And I'm also going to fill up the blanks that we have here. So this oxygen over here, you notice it's kind of blank. There's nothing there. So I'm just going to assume that there's a 1 there. And then I'm going to go to my right side, same thing. There's nothing here, so that's going to be a 1 for that hydrogen. And same thing for the nitrogen, that's going to be a 1. So now we add them all up on each side. So hydrogen on the left side, we have 2. Oxygen, you see that oxygen is on this side, and it's also here as well. So we're going to add both of those up. So we're going to add 1 plus that 3, and that's going to give us the 4. And then for nitrogen, it's just 2. So I'm going to put a 2 over here. I'm going to erase these just to clean it up a little bit. Okay, but we want to know that there's a 1 right there. All right, and then I go to my right side and I do the same thing with what I have here. So for my hydrogen, I have 1. For my nitrogen, I have 1. And then for my oxygen, I have 2. All right, so now I want to ask you this question. Does this equation over here look balanced? Well, let's see. So we have a 2 over here and a 1 over here, so that is not balanced. Same thing here. We have a 4 and a 2 over here, not balanced, and this is also not balanced at the end there. So what we have to do is use our coefficients. So that's going to be the numbers that are in these spaces right here with the lines to balance out the equation. So I'm going to use 2 because I want to multiply this 2 times this 1 to try to get what's on that side as well. Okay. So I put a 2 there, and that 2 is going to multiply times the subscript of hydrogen. So 2 times 1 is going to give us 2. 2 times 1 of the nitrogen is going to give us 2. 2 times the 2 of the oxygen there is going to give us 4. So now let's look. Are these balanced out? Well, yes. 2 and 2, 4 and 4, 2 and 2. So it looks like this this equation right here, these coefficients that we use work out. So let's I'm just going to clean this up just a little bit. So we have 2 blanks on the left side, as you can see. So what I'm going to do is I'm just going to place a 1 on each side, and now it is balanced. So this is our final answer. And this is how we show our work as well, by making sure that we scratch some of these out and, are showing that we can multiply the coefficients times those subscripts. But yeah, that's pretty much it for this problem. This is the correct answer.